Hey guys, finally an MSLA printer prototype update. And I have to say that it finally works. And yeah, I know, as you can see, it's not finished yet, but at least the entire hardware is now working. The display is working, the light is working and improved, the step motor is working, the end stop switch, the menu and the settings, everything is working. So now all I have to do is to finish the final PCB, order it once again at PCBWay, and then finish also the enclosure, because this took me some time to fix it, and then I had to make a lot of changes to fit the new PCB, and then finish the upper side. And then we'll have a complete MSLA printer made with Arduino, well, ESP32. So in this video I want to show you all the updates, how I fixed the errors that I have in the previous version, how I fixed the light and also improved the light with some lenses, how I fixed the TFT display, the M-stop switch, the stepper motor, the code, and now we have a cool menu. You can select the settings for the printing height, the exposure time, and so on. You could also now select different folders from the SD card with the menu, so in that way you can print different prints from the same SD card, and a lot of other improvements. That being said, let's get started. What's up my friends, welcome back. So let's just start this video with the first test. As you can see now the printer is working. Now it's not printing with resin because I still have to design the vat and make some supports below the screen, because otherwise the pressure will just break it. But anyway, I want to show you the test and how the hardware works, explain a little bit how to print and pass from an STL file to a resin print, and then I will show you the improvements that I have for this version, some future improvements that I have to make for this entire project, and then how we'll finish it in the next months. So let's just start with a quick test and show you how it works, talk a little bit about the new design of the PCB and how I fixed the errors with that, and also the improvements that I made to the entire printer, and then in the next months assemble it. So let's get started. By the way guys, in this video I will show you a few PCBs that I made with the awesome PCBWay, as always, the sponsor of this video. But you will see that I will get rid of this PCB, and by the end of the video you'll see that I will get rid of all the PCBs and merge everything in only one PCB. Just one PCB for the entire project. And for today you will see that we will be working with this, which is a prototype, but at least I know that this works. So I had to make a prototype to be sure, make the new schematic and place it here on only one PCB. So you'll find the new schematic and the new PCB below if you want to make the same project. Go to PCBWay.com, upload the Gerber files that I'm sharing for free, select the settings and make sure that you select the black color, because the darker it is, the better, because you don't want to have reflections on the other side. We'll talk about that in the video. Order the PCBs and you have just one PCB for the entire project, merge all together, and you can start making tests as I did and make your own MSLA printer, learn how to use it, learn how to make it and how it works, and even improve this project. So yeah, thanks to PCBWay for supporting these kind of videos and making these awesome PCBs. You will see that the quality of these PCBs is amazing. So just download the Gerber files and now let's check the printer. So let me show just a quick overview of the entire printer. The vat will go here. Now this is a vat from an old printer, so mine will be a bit smaller. It has to fit on these holes here. Then we have the TFT display that will create the pictures. We have the UV light below, the stepper motor and the end stop switch. And then we have the control PCB, which will be fixed on another piece that will go here, which I haven't printed yet. And then we'll have the control here. So let's just make a zoom on the screen and show you what we have now. So here we have the main control PCB connected now to the internal PCB. And the first change that you will see is that now this main controller PCB is made with a proof board or a prototyping PCB, because I had to change the design of this one. So I told myself, let's just make a prototype, make sure that the hardware works, and then redesign this PCB so I don't have to order it once again, solder it once again, and lose a bunch of components. So now the main control PCB is a prototype one, which I'll show you in just a moment. And also the PCB for the screen is changed as well. You will see that it has some different connectors, but we'll go over that in just a moment. Let's just see this one and show you how to control it. On this PCB we have 4 buttons, left, right, up and down, and an OLED display with a menu. And we also have an RGB LED, which I haven't connected yet because I don't want to use it yet. And this on the menu can go up and down with these buttons, and as you can see we only have 3 settings. For the settings, for now you can only change the exposure time of the UV light and also the layer height in millimeters, which is now set to 0.05 millimeters and 3 seconds of exposure time. And I'll add more settings in the future. And for the move, the only thing that you have is to home the machine using the end stop switch or to move it up and down. And then if you go into print, now I have an SD card inserted, and if I enter, as you can see, I have all the files on the SD card, and these are the folders on the SD card. Remember that inside of each folder, we have the pictures for each print. So if you select one of these, it will ask you if you want to print it or not. If you click no, you get back. And with this button, you go to the main menu, and if you click that do you want to print it, so you select yes, it will start homing. Now, since I don't have the z-axis, it will home forever, so let me just move the camera and show you the process. So right now, as you can see, it's homing, but since I don't have the z-axis, it's homing forever, so all I have to do is to stop the switch with something, and then it will change the speed and home it once again, because with a lower feed rate, with a lower speed, the precision of homing is a lot better. So as you can see, if I place something in between, it stops, it goes up and then down with a lower speed, and then it homes once again, and now it says homed, and now the print will start. As you can see, we already have the first layer, the UV light starts, you have the percentage here, 14%, and the name of the picture that is printing. Tower 1.jpg, 28%. I only placed like 6 or 7 pictures, so each picture represents like 15%. Now we are 42. So as you can see, it goes up and down, prints a layer, then up and down, prints another layer, then up and down, prints another layer, and between each up and down, it will subtract 0.05, which is a layer height, and that's how an MSLA printer should work. Now here we have the same process from above, the homing process. Now slowly, now it's homed, and it will start. We will see the first layer. As you can see, we have the mask, we have the shape of the object, and the UV light for 2 seconds, I think, or 3. I think it's 2 seconds. It goes a little bit above, then it lowers, then the next picture, which will be different. This is a different shape. I've placed some random layers from this print. Is not in order, but as you can see, that's what it does. It creates a mask, and we can only see the UV light where the mask is not black. So as you can see, now I have the printer open, and you see that the prototyping PCB is inside there, and now that it works, I am designing the new PCB and order it once again. And what I want to do is to make it fit everything on just one PCB, not one for the driver, one for the LEDs, one for the controller, and another one for the LCD screen, the TFT screen. So I want to make a PCB that will have everything, and you only have to order one, solder it, and have an MSLA printer. So let's just start with the screen PCB, tell you what I've changed and what it was wrong, and then we talk about the main PCB, the light PCB, and so on. This is the most important PCB for this project. It's a lot bigger than the other ones, so it will cost you a little bit more, but it's the most important one because this is where the screen will go. Now this screen is kind of expensive, it's like $20. I mean, it's expensive if you buy it multiple times as I did, because I've already broken like 3 or 4 of them. But anyway, if you take a look at the first version and the second version, they are kind of the same. The only difference is that now this PCB has a different connector. It still has the old connector, but you see, this connector was very fragile, so I had to remove it. I had to use a different one, and also the resistance of the wires that I was using, which are called flat wires, I think, or band wires. And I'll try to place some on the screen. The resistance of those wires is very high, so I had to use a different connector, which is not optimal neither, because this one is too stiff. So I'm deciding on what type of connector to use, because as you can see, we are using like 8 or 9 cables, wires, and we still have to connect 2 pins for the fan if you want to add an external fan as well to remove the smoke, to remove the odor from the print and the bad fumes. And yes, we will need like 11 wires, so I still have to decide what type of connector, because for now I'm using this one. Works great, but since it's that stiff, it already desoldered or broke for a lot of time. As you can see, just by now, one wire already got disconnected. So yeah, this is not the best option for the wires, so I have to think for a different one. Then another change is that now I'm using a 4-inch display, not the 3.2 one. So this is a bit bigger, and I'm still printing only JPEGs. I'm not able to print PNGs, because the software that I'm using to pass from an STL file to pictures is only generating PNGs. But for now, with the libraries that I have for the ESP32, I can only print PNG files from the flash memory and not from an SD card. So that means that you have to load the picture to the flash memory in a byte format and then print it from there. I would like to have a PNG decoder and print directly PNGs. Actually, I would like to know a software or a code that could get the Box file, the .ctb I think it is, and pass that to pictures and then print it on the screen and not have to pass through JPEGs. But now I'm printing JPEG of 4 inches. The display is a bit bigger. As you can see, I've covered it with some aluminum tape, which is good for avoiding noise, but is not good for reflection because this should be black. So I will try to cover this with some black tape so it won't have too much reflections from the light. And on the top side, I've covered with some Cotton tape, and I still have to design some sort of support below here so when the print is printing and it makes some force on the screen, it won't push it inside or break it. So I have to make some sort of frame here on the inside, and that will hold the screen in place. It has a pin for the fan, the external fan. It has 3 pins for the sensor. It has the pins that are going to the TFT display, which I made the tracks shorter because the shorter it is, less errors you will have, less noise. And then we have this hose, which will be used for mounting the resin bath. And that's it for the main PCB for this project. It looks kind of awesome with this transparent display, doesn't it? The next PCB that I've changed is the main controller one. As you can see, this is the one that I had, and now I have a prototype. But now that I'm sure that the entire hardware is working, I'll design this once again, and then as I've told you, I want to make it everything on the same PCB. So all I have to do is just pass this schematic on the new PCB, and that's it. So let me just take it out and show you separately the improvements and the schematic changes that I had to make. We have the wires that are coming from the screen. That's out. We have the wires that are coming from the stepper motor. And then we have the power cables, we have some screws, and this is just held in place with some pins. As you can see, it has its own pins. I'll take it out. We have the pads for dissipating the heat because this gets quite hot. And then we have the MOSFETs here for the power, the SD card here, a buzzer, and the ESP32 and some more components below. And this is the stepper motor. So let me just take it out and show the connections, and these are the connectors for the display, for the TFT display. So here I have the main controller PCB, and as you can see, it's a mess, but at least this one works compared with this one. So what was wrong with this PCB? Why I had to make so many changes? Well, the first error that I had is a very dumb error, and that's because I'm very new to the ESP32. I mean, I've been using the ESP32 a lot this last year in 2024, but not as deep as the Arduino. So I'm still getting to know the entire board. So I didn't know that the pins from 39 to 36 are input only. And I've connected those pins to a bunch of stuff that was outputs, In this case, the stepper motor driver, which is this one here, was connected to those pins, if you check the schematic from the previous video. So I wasn't able to even move the motor because those pins are only input. So if you want to make the steps and the direction pins, you can use those. And that was the first error. So I had to rechange this design and select different pins. Okay, let's just see another change that I had to make to improve the project. So you'll have the final parts and the final schematic. As you can see here, I have some changing for the pins that I've used, but the updated schematic and the entire files will be below if you want to download it. And now I know for sure that the hardware works. So if you want to try to make the same prototype, you can just download the files from below and make it yourself and improve it even more if you want. And at the end of the video, we'll talk about why I'm making this project. I know that I had a lot of comments that buying one is just $400. Why spending so much time and making one for myself? And those kind of comments are from people that I think don't know what learning is, because this is a learning channel. Anyway, that's for the end of the video. So the next change that I've made to the schematic is using a buck converter instead of a linear regulator for passing from 12 volts to 5 volts. Now the ESP32 already has a 3.3 volts regulator, and that's okay. But you see, the entire circuit that works with 5 volts or even 3.3 volts was using too much current for the poor AMS1117, which can only deliver 1 amp of current. So this IC, this regulator, was burning out all the time. And because of that, I burned one LCD, I burned 3 ESP32s. That's why the ESP is now with female pins. As you can see, I can take it out, because at first it was soldered to the PCB, but when I've seen that I was burning ESPs all the time, I had to change it and use the female pins. And that's because this IC was getting burned all the time. And when this IC, the AMS1117 was getting burned, 12 volts were directly connected to the ESP32V in pin. So by that, it was burning the 3.3 volts regulator, so the ESP was getting burned, and that is connected then to the rest of the PCB. So that's a huge mistake. Instead of using a linear regulator, I've used a buck converter set to 5 volts. This is also a lot more efficient, but this one creates a lot of noise. But I'm not using the 5 volts for anything because this is connected to a capacitor to filter the signal, and from this I connect it to the 3.3 volts regulator of the ESP32, which is a linear one and has a lot less noise. So then I'm using 3.3 volts all around for the TFT display, for the SD card reader, for everything, and that works just fine. Another improvement that I've made also for the main board, because I've told you that I want to place the LEDs, the driver and everything on the same board, so it will go like this. I've added these lenses, and I've seen this to a lot of other printers, that if you add this lens of 45 degrees, it will improve a lot the light penetration, and the light will go always upwards towards the screen, and in that way you will get a lot more uniform light on the display, which is what you want. You don't want to have a stronger light on this side and less on this side, because in that way the print will solidify more here and less here. So we're using these lenses, which cost like a few dollars and are specially designed for these LEDs, which are SMD. Just snap it into place and then you have a lot better light for the UV light. Another change that I've made to this project is adding a buzzer, because a lot of times with the printers you want to have sound notifications for when you're starting the print, when you have an error, when you're finishing the print, or maybe even add a beep sound when you're moving up and down with the menu. So having a buzzer will help a lot, and I had to make sure that I connect this buzzer to a pin that was able to make PWM signals, because at first, once again, I'm not used with the ESP32. I've used it for a different pin that was only output, only input, but now it's connected to a good pin and it creates sounds, beeps. And that's not a major change. Another small change was using this TMC driver instead of a normal A4988, I think are the drivers. And this is a very silent driver, so now the stepper motor moves a lot smoother, it has a lot more torque, and also doesn't create any vibration, which is something that you don't want with this printer, that the screen will vibrate or the light will vibrate. You need a smooth movement. So using a TMC 2208 in this case, and cost me like $7, it's a big improvement for this project. Okay, another update improvement was based on the original design of the TFT display PCB. And as you can see, these are just some of the displays that I broke down. That's why this was kind of expensive. But if you take a look at the PCB here, we see some small components which I haven't added to my PCB because I thought they are not useful. Some capacitor and a transistor. For example, there is one transistor connected between VCC and ground, and then the gate is connected to ground. So basically that transistor is always on. So I thought I shouldn't add it because it's just a transistor. So basically making just a wired connection would be the same, right? Well, I'm not sure why, but they are using this transistor. I think it's just to add a small delay between when you are turning on the system and when the display will turn on, and also maybe add some resistance to limit the current. I'm not sure, so I've added that as well, and I think the SPA connection improved, because at first I had to reset the PCB a bunch of times, like 6 or 7 times, till the till the TFT display was turning on. So I had some problems with the communication of the SPA system, the SPA communication. We also have a small diode that is connected to the CS pin, which it looks that is very important because that pin must be low when you start the entire system and make the reset. So adding that diode will help with that, and also add a capacitor to that transistor as well, improve the connection. So I've added all those, and now the system works a lot better. So yeah, it turned out that these are useful components. Don't know why I haven't added this to my schematic in the beginning. Oh, and by the way, the other transistor is useless for us because that was connected to the backlight of the screen, which we are not using anymore. So the other transistor, we don't have to connect that because now we have our own backlight, which is the UV light. Okay, so what other updates we have? Now for the 3D design, I've relocated the placement for the hole of the SD card and on the side, because now the PCB will go like this. So this module here, which is the SD card reader, will go here, because on the other side, on the other PCB, I had it here, so it must go on the back end of the case. which will also have this, which is the Z gantry, the Z axis, and as you can see, it's quite thick. So we needed this hole here. So basically you have to fit your finger inside there and add the SD card, which was quite impossible. So what I had to do is maybe use some tweezers, get the SD card and fix it there inside of that hole, and that was awful. So having the SD card here on the side was a lot better, but if I change the entire PCB that will go here with the circuit, probably we'll have the SD card right here, which is a better placement. So that was also changed. The same for the power connector, the same problem. As you can see, we have this hole, but in this case it's a lot easier to just take the jack and fit it inside of the hole, so that's not a problem. So I think I'll keep the power here behind, and also I'm thinking of changing the position of the fan more close to the UV light, which is the part that will get hotter, and I think that's it. Finally, the last design that I have to finish is the Z-axis, which basically, I mean, I will have a vat here, which I also have to design. It will go right here, and then I have to add some sort of connection, a 3D printed part, to this linear slider here, something like this maybe. This is also taken from a different printer, and that will go here, and it will also have some sort of pin like this one that will go inside of the sensor, and with that we decide the Z-axis, the Z-axis home position, and this will hold a ball head, and that ball head will have this part here which is made out of aluminum, and this is the printing bed. This is where the print will stick. As you can see, I've used it for some tests for the laser engraver, but anyway, so that's the part that I have to finish. Design this connector here that will hold the entire gantry in place, the entire bed. Okay, so what is there left to do to have a finished working MSLA printer? Well, it's very easy. Pass the entire schematic from this prototyping PCB to a new PCB and order it, assemble it and test it out, and then change a little bit the design of the case. The main case will be kind of the same, just change the position of the SD card and add some other small improvements, assemble it and make the first test. So that's pretty much it. I hope that I'll be able to finish this in 1 or 2 months. I would be able to finish it faster if I was only focused on this project. Obviously I have a YouTube channel and I can't do that. That's why it took me so long to make this new update. Actually, I was ordering a lot of boards. You will see that I have a box here full of boards. Let me just show you. These here are just other versions that I've tested and I failed. So obviously order the PCBs, wait for them to arrive, change the design, and at the same time work at other projects took me a lot of time. So finally I'm back to this one because a lot of you guys commented that you still want to see the finished product. So that's it. Make the PCB, make all the updates on one PCB, order it, assemble it and test it out. So stay tuned for that. Now let's just talk about some of the comments that you left me on this video and maybe have some answers for that. Believe it or not, I've just talked for like 5 minutes without hitting the record button. Anyway, let's just see some questions. And this is one of the most commented questions that I had on this project. And basically a bunch of you guys are saying, why making an MSLA printer from scratch, wasting so much time and so much money, when you can just buy a MSLA printer for like $400, which has way better resolution, 4K or even 8K resolution, the light is a lot stronger, the result quality of the printed object is like 1,000 times better than this will be, because I mean it has 4K or 8K resolution. So I just make one. Well, first of all, you have to have in mind that this is a personal project. It's something that I wanted to learn and make for a long time. So this is for me, but since I'm a YouTuber, I'm sharing all the files in case that some of you guys also want to know how it works and make one. And the second part is that this is a learning channel. So everything that I'm making here is not to have a finished product. A bunch of times I'm seeing comments on my projects like, instead of just wasting $50 and make something, why not just go and buy the same stuff with like $20 on AliExpress? Well, because a lot of the times it's not about the money that they are putting into the project, but understanding how it works. So for a lot of my projects, I was spending like 3 or 4 times the price that it cost to just buy the product in order to make prototypes and learn how it works. So this is the same. Now that I know how it works, I've spent a lot of money, but maybe in the future I can improve it. Just have in mind that on my project, on my channel from the beginning, like 8 years ago, I haven't released any product yet because my channel is about learning and not making products that will go to the market. So please stop comparing my project with the products that you have find on the market, because I'm not a company that is designing products and launch them to the market. These are just prototypes, me learning and sharing my learning with you guys. And the third part is that now that I'm learning how it works and I know how it works, maybe in the future I can make something even better than something that you have on the market. Even if it will be more expensive, it can be better. For example, just a few months ago I showed this screen, and this also works with the ESP32. So just imagine passing from that very small TFT display to this one, which is 1K, 1024 pixels. So you'll have a lot more build volume, a lot more resolution, and it's just like $10 or $15 more. So for $15 more, you get a bigger screen. Imagine that. Now that I know how the hardware works, the only change that I have to do is the screen, and maybe even get a monochrome one and improve the quality even more. And beyond that, I can go maybe with a Raspberry Pi, which is something that I've already thinking, getting a Raspberry Pi, and instead of using an SPI screen like this one with low resolution, just buy a 4K monitor for like 50 bucks, maybe even second hand, and connect it to an HDMI adapter, connect that to the Raspberry Pi. I want to create a website that will get your 3D file, slice it, get the pictures, send that to the Raspberry Pi in Linux, and then just print that picture to the 4K screen, and like that you have like a half-meter resin printer for like, I don't know, the Raspberry Pi and the screen maybe less than $300. So just by knowing how this works, which is a prototype, maybe in the future, me or even you guys, because I'm sharing this with you and maybe some of you guys will have a better idea, could improve this project. That's why I'm making the prototypes and sharing everything for free with you guys, just to get more knowledge, and maybe someone in the future will get some product to be improved. So just to make it clear, my main goal is not to get a cheaper version or a better version that you already have on the market, because right now that will be impossible, because the resin printers are now at 8K or 12K resolution, but is to know how it works and maybe make a low-cost version as a prototype, and improving that design to maybe make a DIY version or something that people could get and not just use but also learn how it works. That's my goal. Share the knowledge on this entire journey of the MSLA printer. Okay, other stuff that you commented is that this would generate a lot of heat and it should need a heatsink, and yes, that's why I've designed it like this. This, for reference, is the LED module from a different printer, an old one, and as you can see it has a heatsink, so basically that's why I left these pads here. And also we have those pins with some spacing in between, so I could place this at a different height so it will fit a heatsink here, a heat dissipator. So we'll add some thermal paste or maybe some thermal pads and add the dissipator here, because this generates a lot of heat. So if you have a print of like 1 or 2 hours, it might damage the LEDs. Okay, so here I have some more ideas and options that I should use for the screen. First of all, this is a normal TFT display, so basically it has the RGB pixels, but this one is from an old printer. This is a monochrome display, so this is using just one pixel on or off, so it creates a perfect mask. But this, on the other side, you are losing 2 pixels because you are using 3 colors for just opening and closing the light, because the only thing that you have to do is to create a mask. You don't need colors. So using an RGB TFT display is not the optimal solution. I would use a monochrome one, but I haven't found any monochrome display compatible with any library for ESP32. That's why I haven't used this kind of display. Another option is to use the display from a smartphone and basically maybe create an Android app. So you'll have the display here, and then the Android app will do the same that the ESP is doing, controlling the pictures and so on, because this could go up to 4K. We have a lot of very cheap smartphones nowadays that have a 4K display. So that's a very high resolution compared with this one. Oh, and by the way, another cool idea that I should also apply to my project is to add a resistive glass like this one. This is a protection glass and it was glued on top of the screen, and basically this will protect for any objects falling and breaking the screen, or maybe the print pushing too hard. So basically you have first the glass and then you have the screen, and like that you add a lot more protection to your printer. I should also include that into the design. Yet another thing that we should talk about is the printing bed. In my case, I will be using this piece of aluminum, and this has like a rough surface, so the print will stick to this base. but the problem is how to level it. Now I've shown you that the printer will just go up and down to level the z-axis, but then you also have to level the bed. Now this is from yet another printer, a very old printer, and usually you have like 4 screws in order to be able to control each corner. But my idea, instead of using this kind of support with 4 screws, I want to use a ball head, which would be something like this. Nowadays, a lot of the printers are using this kind of ball head. Actually, it's a lot bigger because this could move in and out with a spring inside, but then also you can move it freely in all the axes. So all I have to do is to make a hole inside of this aluminum plate. As you can see, we have some patterns, that doesn't matter, and then fix it here, and now we'll be able to set the Z level to be flat on the screen. And not just that, but also control the height using a spring inside of this. And once I tighten it up, once it's tight, I can set Z0 on the screen, and that will be my 0 position, because now the height of the bed is exactly on top of the screen and also is very flat on the screen. And that should be the Z-axis. It's an easy setup, but I'm not sure if it will be perfect, because this might move during the print, and it's something that we don't want. And finally, let's just make the sum of the total price of making this, because a lot of you guys were commenting that obviously it is a lot cheaper to just buy a printer with like $400. It wouldn't be cheaper, but it would be better, because the price that the dollar that you get for the quality is a lot better with a printer that you just buy. But this is being a DIY project and the prototype and something that I do for learning. Obviously the price will be a lot higher, but let's just see how much it will cost to make it. Well, I think that the most expensive part of this project was the big PCB. It cost like $20 to make it, but you get 5 of those. So if you were to make 5 of these printers, you only pay like $4 for one PCB. So it's not that expensive. The rest are just normal PCBs. You can get those for $5. And actually, if I were to make the entire schematic on just one PCB, it would only cost you $20. Then the next most expensive part will be the screen, which I bought for like $17, if I remember correctly, $14 or $17. The ESP32 is a clone. I bought it for like $2 or $3. The LEDs are very, very low cost, just like $2.50 LEDs. And then the lenses were a little bit more expensive, like $4, 20 lenses, and you don't need more than that. Then the step driver cost me $8. It's also a more expensive one, is the TMC, but if you want to use the normal Pololu drivers or A4988 drivers, those cost like 50 cents. So it's your choice. So $8 more for the driver. The step motor is like $7 to $10, and it already includes the lead screw. And then the entire frame of the printer was made with like half a spool of PLA filament, which I buy here in Spain with like $13. So half would be $6 more. And what more do we have? Stuff like this, screws and ball bearings, is $1 each. So let's just add for all the screws, all the washers and everything else. Let's just add like $10 more. So I think that would be it. Maybe the piece of aluminum would also cost you like $5. Depending where you buy it. And for the vat we need some FAP film, which is this plastic here, and this costs like 50 cents a sheet of like A4 format. And then you obviously need a power supply, which in this case I haven't even showed you because I was using my power supply for the workbench, and you need like 2 amps. So a power supply of 12 volts and 2 amps cost you, I don't know, $6 on AliExpress. And I think that's it. I think that will be the full list, and maybe that would cost you like $60 in total. I haven't made the sum yet, but maybe when I will be editing the video, I'll place the total price. But it's not that expensive being a prototype. Imagine doing this to sell it. It will be a lot less, because you pay $20 for 5 PCBs and you could make 5 printers. So in that way, all the components would cost a lot less if you're making a bunch of these printers. So that's my idea. I'm not willing to sell this project. That's why I'm sharing it for free. This is open source. But what I want to do is to get better and better, and maybe in a few years, get to even work with 4K screens and make an open source printer for myself, for learning and share it with the community. That being said, I think this is the end of this update, and this took me a while to solder. I had to solder like 3 times. I've already told you that I've burned out the ESP32. So this video is a bit different because usually I record while I'm soldering the PCB, but this time I've made the PCBs, I've made the test, and once I was sure that it will work, I've recorded this update just to share with you my opinion and what I found out and share all the changes. So you will find all the links below for the entire project if you want to replicate it, and all the help on electrons.com. And if you like this kind of projects, obviously consider supporting me on Patreon or any other links that you'll find below, and maybe talk with me on Discord, and that's it. Thank you very much and keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it, and the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.